Hi, we're here at West Edmonton Mall, one of the biggest shopping malls in the world, and no surprise, it has one of the biggest parking lots in the world. Now there's something very interesting about how they constructed these upper level parking lots. It turns out it's not one massive piece of concrete. There's actually separate slabs of concrete that have been pieced together, and in between those slabs are these gaps. And these gaps are quite large. They're about 4 to 5 centimeters wide, and they're filled with foamed rubber. Now, one has to ask, why would they construct this parking lot with separate slabs and include gaps? Well, it turns out it's for the same reason as you find those gaps in your sidewalk, a typical sidewalk in front of your home. These gaps protect the structure from thermal expansion. To understand thermal expansion, we have to remember that the particle model says that particles move faster and further apart as the particles gain heat energy. So a slab of concrete, when cold, will be a certain size. But as we add heat energy, say from the heat of the sun, this will result in the concrete slab actually increasing in size. Engineers must plan for this expansion. So when constructing with multiple slabs, space must be left to allow for expansion of the individual slabs. If they don't, the concrete will crack and break. Engineers have long known about thermal expansion, and that it plays a role in the way things like railroad tracks must be built. In parts of the world where temperature changes a great deal, railroad tracks must be laid down with significant gaps between one rail and the next. The sections of rail have to be kept shorter to allow for expansion. Did you know that 500 meters of railroad track will increase in length by 30 centimeters with a temperature change of only 26 degrees Celsius? If engineers don't account for this, expanding pieces of track would buckle and twist. And if a train were to run over such twisted track, there could be disastrous consequences. So that's why, if you look closely, railroad tracks are secured in a way that allows them to expand. So now that you understand the importance of thermal expansion, think about the times you've driven over bridges and heard the clunk 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 noise as your car passed over gaps. Almost all bridges in areas with changing temperatures are equipped with expansion gaps. What do these gaps do? And what would happen to a bridge if it didn't have them?